so many different purposes to send this satellite. One of the major thing is to do the communication. Yeah, like our internet communication. Nowadays we have internet cables also, but internet communication. You must have seen in so many movies, right? Like people used to talk on satellite phones. What do you mean by satellite phones? Those phones are connected with satellites, and then those satellite connects with other phones. Those are satellite. Everything because of the satellite. The um, you can say internet connection. Sorry, the communication part. And as you can see, he was like he finalized, he shaped, refined, and designed the Chandrayaan 1 Mars orbiter mission. He was the main person behind it. Yeah, like one of the main person. So let's see the next one. Okay, so here is the picture of Aryabhata, India's first satellite. Obviously, it was unmanned satellites. Okay, unmanned satellite. That means there was nobody inside the satellite. Assembled in Pune near Bangalore. That's a place called Pune, and it was launched by Soviet Union, again USSR, or you can say Russia, in 1975. And it was, as you can see the detail, I'm just dictating so that you can, while you are seeing, you can just go ahead with it. 360 kilograms, it's a huge weight. And instruments, which were the instruments? Conditions in Earth's ionosphere. Ionosphere is one of the layers, in Earth's atmosphere. I don't remember like which one proper one, but yeah. And it measures the neutrons and the gamma rays which are coming from outer space, from so many different objects out there, like neutron star, then gamma ray burst, and then some supernova is happening, or the black hole. And with that, even X-rays are coming. So investigation of those X-rays for astronomy purpose. Now, those who don't know, what do you mean by astronomy? Astronomy is basically study of everything about Earth. You can say anything like sun, moon, planet, stars, galaxy, whatever it is. Yeah, everything comes in astronomy. Yeah, so this was the great thing, but one unfortunately it was like the scientific instrument has had to be switched off during the 5th day because of some electronic power supply failure. But yes, it worked, and that was a nice thing. Yeah. Let's go to the next one. And here's the man. Everybody knows him, right? He's Mr. Dr. APJ Abdul Kalam, and our former president. So in 1969, he was transferred to ISRO, where he was the project director of the SLV, as I told you, satellite launch vehicle. Again, I'm telling you, like the satellite which you want to launch in space, we put it inside this, and those are satellite launch vehicles. The third one. Okay. So here we started with the satellite launching vehicles. Okay. And as you can see, the purpose was to develop the technological capabilities required to launch satellites. Now we actually bought it sometime for USSR, like sometime for somebody else. Now we have to develop ourselves, right? Like we have made Rohini rocket, we have started doing this also. So first flight of SLV-3, they call it SLV-3. It's the third rocket. Okay. And it was our first experimental flight that took place on this date. As you can see the date. 1 second. Yeah. So it went up properly because of that faulty valve. It just crashed into Bay of Bengal. But obviously we tried, and we always go ahead, right? That's what we do. So that's what we do, and we have done that. So on July 18, 1 year later, you can say 11 months later, SLV-3 was successfully launched from Sriharikota range, and the Rohini satellite was there in that. So we need failure to go for success always. And that was our second satellite called Rohini. And after that, so Rohini series consider 4 satellites. So as you can see, by SLV, and 3 of which made it successfully to orbit. One couldn't. The first one which we actually did, yeah. So post 1980 launch, there were 2 more launches held in 81, 83. And they actually took remote sensing satellites, basically Rohini satellites in Rohini series. And we actually put them in properly in the orbit. That was the success story of ISRO in past. Let's see few more satellites. Like I told you about 3 satellites. So these are the name of 3 satellites. They call it RS1, RSD1, RSD2. They have their some particular uh, nomenclature. Nomenclature means, you give some particular name, like they have some full form, and so you can see they have those satellites were carrying different things. For an example, RS1 was carrying little sun sensor, magnetometer, and temperature sensor, and body was made up of aluminum alloy. Then RSD1 was carried. It was carrying solid state camera and linear array of detector. Linear array means, in one line the detector were there, few different detectors or maybe the same detectors. And RSD2, you can see onboard processing capability to use the data, of clarifying the ground features. One by one we send the satellites with different advancement, with different features, so that we can cover up everything. As you can see, features like water, vegetation, balance, clouds, and snow. Our main aim was that only, right? We have to like find out what is going to happen on Earth, like what is happening. We can click pictures, we can understand, we can maybe predict future, maybe. Everything it doesn't work, but yeah, we can predict future. Okay, let's see contribution of Mr. Abdul Kalam. So I believe you must have seen this picture. I told you it was there in video. Like they're actually making the rocket part, sounding rocket part in like garage, and they are making it. Um, so as I told you, he was the director of this SLV3 project, and which actually deployed successfully Rohini satellite. Now the next step after SLV, there are few more steps, but Dr. Kalam was like one of the main contributors in PSLV. I told you full form of it before. It's called Polar Satellite Launching Vehicle. We will see what is it exactly in next few slides. So these are the rocket series that we have started from. We have started with SLV, then we made ASLV, now PSLV, GSLV Mark 1, Mark 2, GSLV Mark 2, Mark 3. Right now, currently we are using PSLV, GSLV Mark 1, Mark 2, and Mark 3. I'm going to tell you what do you mean by ASLV also. Okay. So once SLV worked, then we did a little advancement, We started with ASLV, PSLV, GSLV. It's like one time you can do something, you will like get confidence. Yeah, I can go for other things also. The main difference between these rockets are their payload, or the sensor, the satellite carrying capacity. More heavier the rocket, more different things, different technology, new technology used. And the weight and the size differs. Right? As you can see, SLV and GSLV. GSLV look like big. I'll tell you what do you mean. What is GSLV? I believe I think almost everyone should know about GSLV, but still I'm going to tell you. So the difference between these rockets are the payload carrying capacity, the kind of fuel they use, and the size, obviously. And rockets actually goes in stages. Like there are sometimes 3 stages, 4 stages. Like rocket goes away, then one stage come back to Earth, then second stage, then third stage. So there are different stages of all the rockets. Let's go to the next one. So after SLV, it was ASLV. The ASLV was 5-stage vehicle, as I told you. As you can see, there are like 4. 1 second. Let me just start the spotlight. I believe you can see the red dot. There are these 4 little boosters. Those drop out first. So stage 1, then stage 2, the lower part, then stage 3, then stage 4, then stage 5. The top part, which has the main part satellite. So it has 5 stages. And as you can see, payload capacity was almost 150 kg. As I told you, all the rockets are, they can carry different loads. And the ASLV has made 4 launches. 1 was successful, 2 failed to achieve the orbit. What do you mean by orbit? Orbit means a stable path around some celestial body. For an example, moon is moving around this Earth, like it's a stable orbit, and Earth is moving around the sun. That path is called orbit. So two of the rocket, they actually failed to achieve the orbit, and a third one went actually, but you know, they decided to achieve some higher orbit, and he achieved some lower orbit. Yeah, but we tried, right? So type made its fate, and this time a maiden flight means you can say the first flight like on 24th March 1987, and final flight was in 1994. So we have stopped ASLV programs, and then we have jumped on the next programs. Let's go to the next part and see what's next. ASLV proved to be the low cost intermediate vehicle after SLV because of the different reasons. Yeah, and you can see vehicle to demonstrate and validate critical technologies. So we started with sounding rockets, then we went to SLVs, and as soon as we got success in sounding, we went to SLV. We got success in SLV, went to ASLV. Now we got success in ASLV at least once also, which is very good. Then we have jumped onto something else, and we will be seeing that. I just told you the name before. Still, one interesting thing before we go to PSLV, if you can recognize the person who is standing in the center, in the middle, is Mr. Rakesh Sharma. He was wing commander, former Indian Air Force pilot. He flew in space with other two cosmonauts. I specifically told them, I called them cosmonauts because they went like they were in Soviet, as you can see, they were in like Russian spacecraft or Russian rocket. You know, Russians call them cosmonauts, and Americans and whole world call them astronauts. But those are the same like people. So that one second, it went away again. Okay, that crew, sorry, the what do you call it? I just forgot the name. The thing in which they sat and went, it was they call it Soyuz T11. I'll tell you the name. I forgot. I'll tell you afterward. Okay. Let's go to the next part. So now we knew about ASLV, SLV. Let's see, and we saw two of the satellites also, Rohini and Aryabhata. Now let's see the advanced satellites which we have developed and which we have sent in space. One of the satellite is called Indian National Satellite. Shortcut is called INSAT. Is a series of multi-purpose geostationary satellite. What do you mean by geostationary? Now, in simple example, if I tell you what do you mean by geostationary, you send something in space. Okay, whatever you send in space, it revolves around the Earth. Okay, if it's in Earth's orbit. Now there is one place in Earth's orbit very far. Specifically, if I tell you the number, it's around 35,786 kilometers from the surface of the Earth. There is this point. Point means that's the orbit. If I go and put my satellite or rocket, whatever, over there and then make it stand over there, that particular satellite or rocket is going to stay always on that location. So that is why we call it geostationary. Geo means Earth, stationary means standing. That particular location is called geostationary location or the orbit. That's around 35,786 kilometers. If you just keep it over there, if you just like able to make a satellite stand over there, it's going to stay. So if I put it on top of India, on all the time, it's going to stay over there only on top of the India, but 36,000 kilometers, obviously. Why do we make that and send it? So, so that INSAT was communication and meteorology. As I told you, communication satellites and meteorology. Basically, you know, to do. I actually forgot meteorology. No problem. I'll get back to you. One of my colleague will tell. Samir, can you like, do you know? I forgot actually. What do you mean by meteorology? Samir, are you there? Your mic is on mute. Oh, no problem. No problem. It happens. You know, there are so many terms that we don't remember. Okay, anyway. So satellite built by
Yeah,
Ford
Parag,
Aerospace.
can you hear me now?
Yeah, I can hear you.
Yeah, yeah, sorry, actually my mic was mute.
No
So
problem.
basically meteorology is study about the materials and the particles which are there inside that inside that
On the planet, on
body or
Earth,
like inside
like
that
that.
planet or like something like that. Yeah.
Yeah, okay, okay, nice, nice, nice. Thank you, Samit. Even I will remember now. Okay, so as you can see, it is made by Ford Aerospace. I believe everyone knows about Ford company, right? It's a car company, and they make different things also. So there were like 4 satellites inside 1A, 1B, 1C, 1D, and satellites sent by NASA's and ESA's launch vehicle. Everybody knows NASA, right? NASA is very famous. And ESA is basically European Space Agency. Yeah. So INSAT system marked the beginning of revolution. In India's television communication. How do you do what? Basically, the race. Everybody knows about the antennas disc, right? That Tata Sky disc. How do they work? They work because of the satellites, telecommunication satellites, and broadcasting and everything. And as Sami told about meteorology, yeah. Let's go to the next part and check what's next. Yeah. So then INSAT 2A, the first multi-purpose satellite built by India. Now we have first we have started making our rockets, then we have started making our satellites. Okay. Then followed by these different numbers. One thing I wanted to just say about this first one. Can you see Kalpana 1? So normally we do it in number series, but Kalpana 1 because of Dr. Kalpana Chawla, everybody knows about her, right? When they were coming back in NASA's space shuttle, and when they were entering into the atmosphere of Earth, and because of some fault in the thermal sheet which is there on you know uh, the particular rocket kind of thing, it there was some fault in it, so it got blasted, and because of that we have kept this name Kalpana 1. She was Indian, by the way. I believe everybody know that.
Yeah,
Okay.
Parag, so sorry to interrupt you. I
Yeah.
guess in the previous slide it was meteorology. Meteorology means the study of weather and no the weather forecast basically. So
Oh,
I read
okay.
it meteorology, that's why I said. But this is meteorology over here. So basically meteorology is the study of weather forecast over here. So we
Oh,
need
okay.
satellites to know okay, how the atmosphere is moving and all.
Yeah, I thought so, but as I told you, like names get confused. So I thought
Mm-hmm.
it has to be there, but okay, cool,
Yeah,
thanks.
yeah.
Okay, next part. Okay. Then, as I told you, after ASLV, there was PSLV, Polar Satellite Launching Vehicle. We started with PSLV, and Dr. Abdul Kalam was one of the main person in that developing PSLV. And you can see in the okay. So PSLV beginning early 1990, and Vikram Sarabhai Space Center. Um, the place where Thumba was there. Then we renamed it and made it VSSC. Please remember the shortcuts, even I keep forgetting. Okay. The maiden flight of PSLV took place on this particular date, but because of some again errors like altitude control error. Anyway, so failure always happens. Like we have seen right from the beginning of the presentation, we have started with failure and then success. Ha. So as you can see, the third line, the first successful launch of the PSLV into SSO. What do you mean by SSO? SSO is basically Sun Synchronized Orbit. First of all, why do we call it Polar Satellite Launching Vehicle? Very interesting. We call it Polar Satellite Launching Vehicle because whatever satellites this rocket is going to send is going to orbit around the sun, orbit around the Earth according to the North Pole and South Pole, the geographic North Pole and South Pole. Okay, not properly on North Pole and South Pole. You can say normally they go with 8 to 9 degree tilt. So if pole is like this, the satellite will go like this. Sometimes it can go up to 20 to 23 degrees also. Still, it's called Polar Satellite Launching Vehicle. Now, why do they do that? The basic aim to do is, it's called sun synchronized orbit. Okay, that means it is synchronized. It is in synchronous with sun. In simple words, if I tell you, if this satellites move on top of the Mumbai, like if it is going on top of the Mumbai at sharp 4 p.m., tomorrow again at sharp 4 p.m., this satellite will be on top of Mumbai. Okay, so that's a we actually need that. Like if I want to click pictures on some place on the same time every day, I will go and I will send the camera in this, because it's going to come on the same place on the same time because of the sun synchronized orbit. Okay, and these PSLV actually used to send those satellites in lower Earth orbit. You can say 100 to 1,000 kilometers. The numbers can vary, but lower Earth orbit. Yeah. So they have sent Indian remote sensing. As I told you, remote sensing, we need to click pictures and everything. Okay, let's go to the next part. As I showed you, as I told you about this, sorry, I forgot to show you the picture, because I kept this picture. It's around 600 to 800 kilometers. As you can see, it is going around the Earth, just tilt a little bit around North and South Pole. And this is the equator, the center line. Okay, that we call it SSO. Okay, success of PSLV. So it's called an expandable launch vehicle, which can replace 1600 kg. As I told you, difference between the launching vehicles was the capacity to carry different weights. It can carry 1600 kg remote sensing satellites and some 1500 and 1050 kilogram small size spacecraft into geostationary transfer orbit. Now, remember I told you some time ago the geosynchronous orbit? That's the same thing, geostationary transfer orbit. It actually goes over that 36,000 kilometers. So this PSLV, we have used it to put those satellites over there also. But as you can see, when it's in SSO, sun synchronous orbit, the height was 600 to 800 kilometers. So we can carry heavy object. But if you are going 36,000 kilometers to carry that heavy object, we require more fuel. It's difficult. So that is why the weight has reduced, 550 kilograms. It's a huge amount, by the way. So after that, this time period, 1994 to 2017, you can see 48 Indian satellites and 209 satellites for customers from abroad. If you people remember, I think in 2015 or 17, he launched PSLV with 104 satellites. 104 satellites. Obviously, most of the satellites were nano satellites. Nano satellites means they were like this much size, maybe 2 kgs or 3 kgs, but total 104 satellites. Most of them were from abroad, and that is one of the way we ISRO is earning and doing good stuff for India. And these are different satellites that we have sent for different purpose. Okay, and last slide. Yeah, vehicle successfully launched 2 spacecraft. Chandrayaan 1, that's most important, in 2008, our Chandrayaan 1 mission, and even Mars orbiter spacecraft in 2013. Everybody has seen mission Mangalyaan. I believe everybody has seen. Yeah. Okay, so these are different PSLVs. As you can see the picture, and height is different. Someone can hold a different weight, like 600 grams, 900 grams, and then they give them different name according to their nomenclatures. And it's 2017. It's over here. I forgot. So on February 15 February 2017, PSLV XL, maybe extra large, 104 satellites, and that was a huge success. Everybody was like, yes, ISRO, India, nice, good. Let's go to the next one. Now, as we have started with SLV, ASLV, PSLV, now we are in GSLV. We call it FATBOY. As you can see the picture, it's like huge rocket, right? Now we call it GSLV because the first line, the geosynchronous satellite launch. If you want to launch any satellite and put it inside geostationary orbit, which is around 35,786 kilometers. We use these kinds of rockets. And I'll tell you, we have used this rocket somewhere else also in the later slides. Yeah, so it was initiated in 1990. And India had first ventured on the path of obtaining cryogenic technology. Cryogenic is basically where we use fuels in, the fuel which we use inside it is very much cooled. You can say they are in liquid form. For an example, we like normally use oxygen, hydrogen, oxygen as an oxidizer. So to make that oxygen is a gas, right? Hydrogen is a gas. If you want to make them turn into liquid, we need to cool them like very down. Like I don't know the proper number, but it is around below minus 150 degrees Celsius. Okay, so when we use those kind of liquid fuels, use this cryogenic, and it's very good. We bought it from Russian technology, we got it from US, and now we are like still making it. We are doing it very good in that. Okay, while in the absence of heavy lift rocket technology, India has been relying France. As I told you, we were taking help from France, USSR. When we didn't have this FATBOY, the GSLV, we used to take help from France. Yeah. Let's go to the next one. So cryogenic technology involves the use of rocket propellants at extremely low temperatures. The combination of liquids, oxygen and liquid hydrogen, as I told you, which gives us highest energy efficiency. Okay, which actually gives us large amount of thrust. Because of that thrust, our rockets moves faster and goes a little more up. Yeah? So that is the cryogenic technology. Continue. Let's see. So ISRO used 7 cryogenic engines by Russia for early phase of its GSLV program to test, and parallelly we developed our own technology also. So GSLV Mark II is the largest launch vehicle developed by India, which is currently in operation, and it's 4th generation launch vehicle. 3 stages. I told you different stages: rocket boosters, base part, top part. 3 stages. And it's capable of launching 2,500 kg into geostationary satellite. That's a huge amount. 2.5 ton. A huge amount. Let's see next. Now we have Mark III also. That's the heaviest rocket after GSLV Mark II. It took about 25 years. Just see this line. 25 years, 11 flights, over 200 tests on different components of the rocket for it to be fully realized, like fully proper, like working kind of thing. And we have used this Mark III M1 for our Chandrayaan 2. Everybody knows about Chandrayaan 2, right? We like last year we did it July 22, 2019, where there was Vikram lander and Pragnan rover. Unfortunately, Vikram lander couldn't land properly and it got damaged. So we couldn't do what we were supposed to do. And anyway, we are anyway going to do one more Chandrayaan. So we will succeed over there. Obviously, like we have already did, right? Like I believe it's 55 minutes we have started. From that, like from the beginning, we are seeing failure, success, failure, success. We are going to do that again. So you can see GSLV Mark 3D will be used for the ambitious manned space mission Gaganyaan. We are going to do that. I'll show you in future slides. After INSAT, we came to GSAT, our India's indigenously developed. We have made these GSAT and used for digital audio, data, video broadcasting. As of 5 December, we have sent 20, out of which 40 satellites are in service right now. Again, they are like communication satellite, right? Let's see next. Applications, different application, different satellites we have sent. There are different names, like few names I've already told you. And then these are navigation satellites. You can see the full form, okay? And you can imagine, nobody can remember that. Maybe people can remember it, but I can't. So Space Science MOM is Mars orbiter mission that we have done, and experimental satellites also. Let's go to the next one. and few more small satellites and academic institutes. Like ISRO have sent few satellites from different colleges also, like which they have like college kids have made a professor with the help of the professor. We have sent that also. Okay, now let's see this. It's called space science and exploration. It's not just the rocketry that we have mastered in. It's not just that the satellite making and sending them. We have also done, space exploration. Everybody knows about Chandrayaan and Mars orbiter mission, right? So these are different things, like Indian space program encompasses research in areas like astronomy, astrophysics, planetary and earth science, different things. And balloons and sounding rockets, I already told you, space platforms and ground based facilities which we have so many telescopes also, by the way, in India, like huge telescopes. One of them is in Ladakh. Then we have radio telescopes in Pune. Like there are so many different places we have. These scientific instruments, basically they read, they see X-rays, gamma rays, and then they learn, they experiment, and then tell us different things. Let's go to the next part of the program. Okay, this is AstroSat, one of the satellites. As you can see, there are different payloads, different sensors for different things. Okay, as you can see over here, the scientific objective of AstroSat mission was understand high energy process in binary stars. Two stars moving around each other are called binary stars. They radiate so many different radiations. The neutron star, black holes, magnetic field of neutron star. Basically, study purpose, as I told you in last slide, astronomy, astrophysics, cosmology, different things. We have sent these satellites. Okay, let's go to the next one. Okay, this is one of the AstroSat best observation. We have like AstroSat has actually observed these galaxies. This galaxy, as you can see the picture, it's like 100 million light years away, which is very far using the sensors which it has. Then something called supernova. Supernova is basically a kind of an event when star blasts. That event is called supernova. Our AstroSat has actually recorded the event of supernova. Like very good, right? Our things, our indigenous thing, Indian things are doing those stuff. Let me show you two more things about GSAT. So you can see, so we are not understanding the graphs over here. We'll just see what they have seen. So these graphs, so left side top graph, you can see as it has seen one black hole also. Okay, there's one black hole and there's one star is moving around the black hole and it's radiating X-ray. I believe everybody knows about X-rays, right? We go, if I broke my hand, if I break my hand, and then they take the X-ray and then they see where the bone is broken. Similar X-rays come from the stars and the different celestial objects also. Yeah. So these are different things which AstroSat had actually detected, and they were like very much perfect. And like this, there are different things. As I told you, this is one of the thing. Which is there's this neutron star, kind of a death stage of a star, and that star rotates very fast and it throws light. We call it a pulsar, not the bike, okay? Pulsar. And it throws the light, and that light comes in any direction after few particular time interval, like maybe 1 second, 2 second kind of thing. So he has detected that also. Overall, I'm just trying to tell you on this auspicious day of 15th August that, ISRO, one of our great institution, world-renowned institution, has done so many great things, and we are still doing it. And there are so many different things which we are going to do. I'm going to show you future slides also. And we are the future scientists, especially kids, and you parents, you can, tell your kids to do something great. We can do it. We have a great institution. Let's go to the next part. India's first mission to moon, Chandrayaan-1. Everybody knows about it. Our launching pad, Satish Dhawan Space Center, right? In Sriharikota, we did it. And it was the orbiter is moving around the moon at the distance of 100 kilometers, and then actually checking everything, like different things that Samir sir said, meteorology. Yeah. One of the great thing of this Chandrayaan 1. I'm going to tell you in next slide. Okay, so the spacecraft carried 11 scientific instruments from different countries, as you can see. Okay, and the work was for chemical, mineralogical, photogeological mapping. Like click the picture. What is the geology? There are craters, mountains, ridges. You know, different things. For that, we have sent this. So there are different payloads. As I told you, payloads are different sensors, like from different countries. People have said these are different scientific payload from India and from different countries. One interesting thing I'm going to tell you about this. As you can see, the fifth one, the Moon Impact Probe. That was the main thing which we were supposed to do, and I'll tell you, it's on top over here. So the main task was this: that this orbiter went in Moon's orbit. Then that Moon or impact probe, he actually threw it towards the Moon. It was going around like very high speed, around 1.7 kilometers per second speed. That probe was going towards the Moon, and it actually collided. Poof! That was the task, by the way. It collided. Poof! And because of that, you know, it might have penetrated a little bit, and whatever was there below that particular surface, it came, you know, it's like bomb blast. The dust and whatever was there, it came in the atmosphere. And then orbiter actually studied what was there inside. But the best part, Moon Impact Probe, when he collided, he actually got to know, not before it was getting collided or whatever the sequence was, we found out that there is water on Moon. That was the main task, and that's what MIP did. Then one of the satellite, one of the sensor, the probe made by America, which is this M3 Moon Mineralogy Mapper, he saw it, he calculated, and then they said that Americans, NASA said that yes, we have found water on Moon, but before that MIP found it on Moon. So that was one of the great achievement by ISRO. And there are then these different things. All the payloads saw the pictures of Mars, and then they study different things. You see, these are overlapping craters. As you can see on Moon, there are craters, all the different bodies in space, like asteroids, meteors. They come and collide and then make craters. So there are different structures on Moon. You can see. You can find out all these pictures on Google, by the way. Yeah. So that was Moon mission. Then our first interplanetary. What do you mean by interplanetary mission? That means we go to some other planet, and everybody knows about Mars orbiter mission, right? Yes. This was the mission which led India to reach Mars. Okay, we are the fourth country. We were the fourth country in the world who reached Mars. The first country who reached in first try. Can you imagine? Like, that was great. And I believe everybody has seen Mission Mars, Mangalyaan movie. I have a small clip. I don't know, my video is not working. Maybe you can see the video. It's a small video. You will like it. So it has been configured to carry out observation and physical features of Mars, different stuff again, like Moon, Mars. And it has different payloads again. One of that is Mars color camera. It click the pictures. I'm going to show you some nice pictures from different heights. Okay, different sensors. That's the video. It's a small video. I believe everybody will enjoy. Let's just see this. Akshay Kumar. You can see how they have struggled to do that also. By the way, this is real story. Okay, characters' names are different, but story is real. They've actually worked hard, and they did it.
Correct, sir. Are we going to have a break or like something like that, or we are going to continue straight forward?
We can continue. We can complete within 20 minutes or so.
Okay. No, because we have a lot of questions with us. So
we can sort out questions first after this video. Yeah, that can be done first.
No, no. We will continue, and at the end only we will sort the questions maybe, because
Yeah, make.
there is a long list of questions.
Oh, okay, okay.
Yeah.
You can see the spot. Oh, 1 second. I just wanted you to see this. Sari dunya se kaho, we can copy that. Nice. Right. It's a proud moment. Okay. It's a proud moment for India. Oh, 1 sec. So these are different pictures of Mars from our color camera from different heights and different resolutions. I'll just show one by one different features of Mars. Some features we can actually see on Earth also, from which we can understand. We can geologically we can tell that in past there was water on Mars. Yeah, that is why we are planning to go on Mars. Earthlings basically.
Yeah,
Okay.
actually, basically, after this talk, we are going to tell about something, that we are going to conduct one course in, astronomy and space science. So that course will be starting from the month of, this month end. We are starting one course, and all the details of that course will be given after the talk. So those who are interested to and like wanted to join our astronomy and space science course can wait till the end. We will share our details. It is like very interesting course, and you all will love it. There are like different topics in it. So just hold on for some time. Then then we will give you all the information about the course, like fees and all, how you can register and on, and like what are the topics that we are going to teach in it. Yes, sir. Alex, continue.
Okay. So GSLV 2, Chandrayaan 2. Basically, everybody knows about Chandrayaan 2. So as I told you, there are three things that were there, and to carry such a heavy thing, like the Pragyan rover was around 27 kgs, the lander was of around 1000 something kgs, and the land and the orbiter was also very heavy. So to carry that much heavy object, like heavy payload, we needed this fat boy. By the way, the Pragyan rover and Vikram lander were supposed to stay there on Moon for 1 lunar day. 1 lunar day means 1 day on Moon, which is roughly around 14 days on Earth. They were supposed to go over there and check different things. As you can see, Pragyan means wisdom in Sanskrit. One of the like great word, but unfortunately it didn't work. But obviously in future it will. Images of uh, Earth from Chandrayaan 2. And Chandrayaan 2 has clicked some pictures on Moon also. As you can see, there are different craters and craters on Moon. But it looks very nice, right? When we see through naked eye, it looks like plain featured. Now, so we have done past, we have done our present. Let's see the future. Future is very interesting. I have one small video again. I know the recording, the audio is not working, but you will like that video. But before that, I'll just show you a few future plans, and we will quickly end this. After Chandrayaan 2, ISRO's upcoming interplanetary missions, Gaganyaan, manned mission, people will sit inside like NASA has done. We will also make people go. And actually, they have started recruitment. Okay, if anybody is interested going in Gaganyaan, you can visit ISRO's website. You can go and check your. Basically, when you go in space, you need to have like solid, super athletic body, and then only you can go. Sharp mind, all those things. If you want to try, you can go. Yeah. So ISRO is working on a total 7 missions. There are different missions. So destination, some of the destinations are Mars. They're planning to do Mars mission again, Moon mission again. That's Chandrayaan 3. Venus mission again. I'm going to tell you about it. Study Sun's corona. Corona is. I'll tell you what corona is. It's going to come after that. And interplanetary space to study. Okay. So here is Sun's picture. Corona is basically Sun's environment, and mysteriously, as if I tell you the proper number, Sun's surface temperature is around 6000 Kelvin. You can say 6000 degrees Celsius also roughly. But Corona's temperature, it's an environment. It goes in millions, and it's still mystery. Okay, nobody knows about it. So ISRO's mission is to send this probe. We call it L1. Okay, Aditya L1 is the name of the mission. We're going to send it to study sun's corona. That's sun's corona. If I block sun's light, whatever environment you see, that's sun's corona, and for that we are going to send Aditya L1. Okay, what do you mean by L1? L1 is called Lagrangian point. I'm not going to tell you in detail, but in basic stuff, if I tell you, if you can just see this picture, this big yellow ball is sun, and this small ball is earth. L1 you can see over here. This is the point where sun and earth's gravity cancels out each other. That means if I go and stand over there, I will stay over there for all the time. Neither sun is going to pull me, neither earth can pull me. It's like stable point. Gravity cancels each other. There are 4 different more points. We are going to make our Aditya L1. That's why we call it Aditya L1. Go over here and stand so that it can see sun and study. Next. So Aditya L1's mission, as I told you. Okay. And we are going to send it in PSLV rocket again. Oh, this is important. Gaganyaan mission, as I told you, India ISRO is sending astronauts to space on a spacecraft called Gaganyaan 2022. Let me tell you one interesting thing. Okay, I'm going to tell you after this. Yeah. So Gaganyaan's crew module, yeah, we call it crew module where people sit. It's ready in the sense we have already been developed the environmental control system so that people can sit. Environmental has to be 27, 30 degree, not more than that. We can't because when it goes in space, it's cool, right? And it comes in front of sun, it's very hot. Environmental control has to be there, and we are like testing and doing some stuff. And let me tell you, our third partner, like my and Samir's third partner, Mr. Nitin Tiwari, who's not over here right now, he's actually working on this crew module's lightning system. Light and how to. It's not like home. I just put one tube light over here and light over here. Everything has to be specific and pre-decided, predetermined, checked, and everything. So he's working on that right now with ISRO. Okay, let's see the next part. As I told you, the second mission is Mangalyaan 2. Maybe we will be sending in between 2022 or okay, and much like Mangalyaan 1, it's going to be the same. Okay, or the orbiter. It won't have any lander or rover. It's going to orbit around Mars and check different things using different payloads and sensors and satellites. Our next mission after this is going to be Chandrayaan 3 mission, and this time again we will send our robot, like NASA is sending so many different robots. We're going to send that. Then Shukrayaan, this is something unexpected and different. We're going to send our satellite to Shukra. Shukra means planet Venus. And as you know, the Venus is the hottest planet in our solar system, and it has very dense atmosphere, so it reflects most of the light. We actually, it's very difficult to understand what is going beneath that atmosphere. Okay, but the payloads, and actually they have not decided, finalized yet, but yes, we are going to do that. Okay, this is one of these satellites. It's called AstroSat mission. Appears to follow up the AstroSat mission that we have sent. Now this will actually, again, as I told you, the satellites which we send for study purpose and to understand universe, it's going to see the X-rays and gamma rays and understand, learn what is happening inside the universe. It's a curiosity that everybody likes. Yeah. And like International Space Station, I believe everybody, like most of you must be knowing about that. The International Space Station made by joint venture of America, Canada, Japan. India is going to make one space station. As you can see, they are supposed to wind up by 2028. Now, nobody knows, it can work after that also, but yes. And we are going to send people by 2022. That's what we have thought. Hopefully everything works well. We're going to make space station also. And let me ask you, everybody knows about Tesla car and Elon Musk. Elon Musk is in news right nowadays, right? And specifically he is in news because the rockets he's sending in space, they're coming back and yeah, standing straight. Reusable rockets, you can reuse that. In whole world, there are I think 3 to 4 companies who can do that. One of them is ISRO. I believe ISRO has successfully done it, but still testing is going on. And one of the like top four, there are only 4 countries who can do that. Like Elon Musk has done it, and ISRO is also doing it. So that we send rockets and we bring them back so that we can reuse them. Okay, and there are different numbers. Like we have done this test flight and it lasted for 770 seconds and reached maximum height of this, and then we brought it back. Okay, so these technology will be developed in phases. There are these technologies that we are going to work on. Hypersonic flight. Hypersonic means the rockets which can move faster than speed of sound. We call it Mach 1, Mach 3, Mach 2, Mach 3, like that. Not Mach, okay? Mach, M-A-C-H. Okay, the landing experiment, how to land properly. Return flight experiment. If we are sending men in space, we want them to come back on Earth, right? And scramjet propulsion experiment. Scramjet is basically, now as I told you, if I send Mark 3 GSLV rocket in space, it requires so much fuel and oxidizer. Because of that, the weight of that rocket is increasing. What can I do to reduce the weight and still send the rocket in space? That technology is called scramjet. We use oxygen as an oxidizer. Scramjet propulsion technology will use oxygen from atmosphere. It will suck inside and it will fly in the space. So no need to make oxidizer tank in the rocket. Nice, right? People are trying. I think somebody has already developed it, but yes, we are working on it. And last but not the least, Dr. Vikram Sarabhai, a journey of 1,000 miles began with a single step. That's what we did, right? Sounding rockets, and now no need to repeat. Everybody knows. I believe everybody will understand. Everybody must have remember, like, अब तो याद हो ही गया सारे rockets one by one, from taking rocket parts on cycles and bullock cart, and then now ISRO India is on Mars, right? One last slide which I've got, which is very interesting, needs to be understand objectives of ISRO. First, mass communication and education via satellite. So this is for future India. Those who like space science, those who like rocket science, you can go and join ISRO. You can work on this. And like Akshay Kumar said, let world know that, copy that, we have reached Mars. We can do that, yeah? Mass communication satellites. Then survey management of natural resources. We need to do that. Using satellites, we can get to know what is below the ground. Even we need for army purpose. Yeah, for spying purpose, we need it because
I mean, people have seen in the movie which movie that recently Vicky Kaushal movie was there, right?
there was one more movie where the Pokhran test
Uri,
is done.
Uri,
Yeah,
basically.
yes, in Uri. Then even in Pokhran test, if you have seen that Pokhran movie of John Abraham, we were actually doing the test, but Americans were actually seeing it using satellite, and we
Parmanu.
could, Parmanu, and we could manage to do it. Okay, and development of indigenous and satellites and satellite launch vehicles. That's what we wanted to do. We are doing it. We are master in it, but we want to do a little more. Good thing. And one last small video, and then we will end. Again, there's no sound, so excuse me for that. I'm running it. A small recap of past, present, and future. You can see that satellite moving. Aryabhata. PSLV launch. India. Chandrayaan 1, the orbiter. Future things that we want to do. Mars mission, Mars landing. These are estimated years, okay? We can do before that also. ISRO Mars station. It will be nice, right? Very good. Maybe one of you kids or parent, one of your kid, like somebody from India will go. Anyone can go. Space station, Indian space station. 2080. And one last part. Obviously, it's like science fiction, but it's very interesting. Yeah, I like this. Garuda, solar sail spacecraft, interplanetary travel with people. Nice. I hope everybody enjoyed. Thank you. And we can start with question answer session.
Yeah,
So should
yeah,
I
sir.
show them
Parag
first
sir,
this?
just yeah, yeah. I mean, if you have, then you can please. Yeah,
Yeah,
I was
yeah,
about to do that only.
yeah. So as Samir sir said before, that we are going to start one basic astronomy course. These are few topics of basic astronomy course. Let me tell you one important thing. Like the first topic says our solar system. This is not a regular topic which you learn in your school. This will be something different and interesting. Few things which you never knew. We're going to tell you about those things, and we will be having some hands-on activities also. Okay, these are few basic topics that we are going to cover 6 days. Okay, so how are we going to do that? We are starting from 29th of August. Okay, it's going to be a 6-day course, specifically on Saturdays and Sundays. That means the weekends. Okay, so if you are starting on 29th August, then 29th 30, then the next one will be next weekend, the weekend after that. Timing is 11 to 12:30 p.m. We might change time a little bit. Right now I have kept tentatively this time because I believe 1 o'clock everybody goes for lunch. Platform will be Zoom. Right now we have, like, you are attending this program, it will be on Zoom. Fees is going to be 500 rupees, so we are charging minimal fees for 6 days. Okay, and if you attend full course, we will be sending you an e-certificate also. To attend this
Plus,
webinar,
plus,
please. Yeah.
yeah.
Yes,
I
sir.
mean, plus there will be some activities also, so it won't be like a kind of continuous lecture
Yeah,
kind of thing.
that's what I
We are
said, right?
trying to keep, yeah, hands-on
Hands-on
activity will be
activities,
there.
hands-on activities, which will make you understand more thing, more detail, in more detail. Plus, it will not make you, that the topics are also interesting, so it goes hand in hand. Yeah. So yeah, that's done. I'm done. Thank
Parag sir,
you.
there is also one advanced course which is coming just next to the basic course. I'll
Yeah.
just give you a gist of the advanced course topics also, so
One
people who
second.
are interested
I'll
might
stop
can
sharing. I'll
yeah,
stop
yeah,
sharing. Yes, please share, sir.
yeah. Just a second. Let me share my screen. Yeah. So can you see my screen now, sir?
Yeah.
Okay. So basically, this was about the first program. Let me tell you about the second program. Second program is basically what we call as the intermediate astronomy program. So first one was the basic program. This is an intermediate program, which will be of there will be 10 different topics, and it will be of so like 10 topics. So it will take around 5 weekends. Sorry for this. This is not 3 weekends. It will be 5 weekends. Okay, and it is starting from the 19th of September 2020. Okay, so just next to the basic course, within like the next weekend, we are going to have a intermediate course, and the course will cost around 800 rupees. Plus, like in this course, we are going to have various advanced topics, and when I call sun over here, so the entire topic will be based on sun. So like every topic here has like more than 1.5 hour kind of kind of a lecture, plus some videos will be there, plus some hands-on activities will be there, which will help you to understand more about it. Then like sun, astronomical distance, what is Milky Way, what is beyond that Milky Way, what is our neighborhood. in our galaxy, what is local group of galaxies, then what is positional astronomy. Like suppose if you are, suppose like when you once you go to the once you go to the outskirts, like how basically you look at the sky, like because now if you look, you will look as a you will look.
Samir sir, sorry to
Yeah,
interrupt, but I think you should
yeah,
turn off the annotations because
yeah, I'm doing that only. Just a second. I'm trying to do it. How to do it? Like I forgot. Okay, fine. I will just clear it out every time. Like no issues. So basically, so we are going to teach you about what is basic astronomy is all about, how the stars look like, what is the spectrum of a star, how the star evolve in their life. Like like suppose the star, like the stars take births and then they die, right? So how basically stars evolve throughout their life. Like what is first of all a star? Like because we all see it as just as a twinkling star, right? So we all have know this riddle, that twinkle twinkle little star. Have you ever wondered? I mean, have you wondered what they are, like kind of thing? So we are going to tell you about all the stuffs over here. Then the very interesting and like one of the hot topic currently that we have is about black holes and exoplanets. Like exoplanets are the planets around other stars. So suppose how to detect exoplanets, what are those exoplanets are, what are the different techniques, how you can find exoplanet while sitting at home. There is one more course which is coming exactly, which will be based only on asteroid hunting. So like suppose if you're sitting at home, how can you hunt an asteroid, real asteroid in the space, just by just by looking at just by sitting at home. So this is how so this is what we are going to do. For the more details, those who are interested can take our numbers, and you can take our email IDs over there. There is a registration contact details are given. So if you're interested in coming up for the course and all, and if you're interested to learn more about astronomy, because these are just a basic course, there is one more advanced course, there is one more hands-on course. We are also coming up with a telescope making course and all. So we are planning to come up with different plans, different programs about astronomy and space science. This is just will give you a gist and like the starting bump, or the starting push in this field of astronomy and space science. So this is what we are going to plan at in the next 2 months. Those who are interested can take our numbers, can take our email IDs. You can send us WhatsApp, or like you can send us a mail that you are interested in. We will send you the details of forms and all. So by that you can simply register to our our courses. So after this, I will go back to the Paraxas, and Paraxa, you can also share. I'm just stopping to share my screen now. You can share your screen, and then you will go. Then we will go one by one for the questions.